Alright, so on the next page you have the ones where the base is between 0 and 1, so 1 over 10. The H is positive 1, the A is negative 1, because remember that's what you see here in the front coefficient, and then the K is 2. So that's going to tell me that the the horizontal asymptote is y equals 2. Notice I haven't changed the domain on any of them. I always start out with that because domain is always all reals. Okay, so this is always going to be all reals for exponential functions. H affects the x, and the a and the k affect the y, so negative y plus 2. So we have 1 minus 1 is 0. Negative 10 plus 2 is negative 8. 0 plus 1 is 1. Negative 1 plus 2 is 1. 1 plus 1 is 2. And negative 1/10 plus 2 is 1 and 9/10, right? Because it's 2 minus 1/10. Okay, so now we're going to graph this. So first we're going to graph the horizontal asymptote at y equals 2. There. Then we're going to plot the points 0, negative 8, 1, 1, and 2, and 9/10. So really close to the asymptote. So it's a very steep curve. It's kind of crooked right here. Like this. More like that. The range is everything below 2, so you say negative infinity to 2, like that. And behavior towards on the right side, as you go to the right, it approaches the line y equals 2. As you go to the left, the graph is going down, so it's negative infinity. The y-intercept is 0, negative 8. Okay, so for number 4, the h is negative 3, because this is plus 3, so we do the opposite. A is positive 3, remember it comes from here. K is negative 6. So then the horizontal asymptote is y equals negative 6. Then x minus 3 is the transformation there. 3y minus 6 is the transformation here. Negative 1 minus 3 is negative 4. 3 times 2 is 6. 6 minus 6 is 0. 0 minus 3 is negative 3. And then 3 times 1 is 3. 3 minus 6 is negative 3. 1 minus 3 is negative 2. 3 times a half is 3 halves. That's 1 and a half. So that minus 6 gives you negative 4 and a half. Okay, so now we're going to draw the line y equals negative 6. That's my horizontal asymptote. And then plot the points. Negative 4, 0. Negative 3, negative 3. Negative 2, negative 4 and a half. About here. And so draw the curve, something like that. Okay, and so then the range is all y's greater than or equal to negative 6, so it'd be negative, no, sorry, from negative 6 to positive infinity. Towards the right, as you go towards the right, the graph is going towards the line negative 6, and as you go to the left, the graph is going up. The y-intercept, we have to replace the x with a 0, so we get 3 times 1/2 to the 0 plus 3 is 3. You could plug that into a calculator and you get negative 5.625 or negative 5 and 5/8 if you simplify it like that. Okay, that's it. Alright, for number 7, the h is 1/2. The a is also 1/2. It's a coefficient right here. And then the k is positive 2. So that gives me a horizontal asymptote of y equals 2. The transformations are x plus 1/2, because h affects the x, and the a and the k affect the y. So 1/2 a plus 2. Okay. Negative 1 plus 1/2 is negative 1/2. 1/2 times 3 is 3 halves, which is, oops, I should have put not an a there, sorry, that's a y. 1/2 times 3 is 3 halves, which is 1.5, plus 2 is 3.5. 0 plus 1/2 is 1/2. And then 1/2 times 1 is 1/2 plus 2, that's 2.5. 1 plus 1/2 is 1.5. 1/2 times 1/3 is 1/6, so that's 2 1/6. Okay, so now we draw the horizontal asymptote at y equals 2. The points negative 1/2, 3.5, so negative 1/2, 3.5 approximately right here. And then positive 1/2, 2.5, positive 1/2, 2.5 about here. And then 1.5, 2 1/6. So 1.5, so it's closer to the asymptote. Again, this is just approximate. So it goes like that. Okay, it's not a horizontal line, it's always getting closer and closer to the horizontal asymptote. So there's the graph right there. The range is everything above 2 greater than 2, so 2 to infinity. The end behavior, as you go to the right, it approaches positive 2. As you go to the left, it goes up, so it's infinity. The y-intercept, we're going to have to plug in and use a calculator because of all the fractions. So 1/3, 0 minus 1/2 plus 2. So that this becomes 1/2, 1/3 to the negative 1/2. Okay, plus 2. So remember, to make it positive, to make it a positive exponent, we have to take the reciprocal. So it's 3 to the 1/2 plus 2. 3 to the 1/2, if you remember from an earlier module, is radical 3, square root of 3. So this is radical 3 over 2 plus 2. So plug that into a calculator. That's what this equals, and you get approximately 2.866. That's a y-intercept. Okay, so for number 8, the last problem, h is negative 2, a is negative 3, and k is 7. So then that tells me that the horizontal asymptote is y equals 7. Again, just a reminder, domain, I haven't changed it. Every problem I start off with it, it's all reals. And then if you notice every problem too, I start off with the reference points, which is based on the base right here. So this is 1 over b, which is reciprocal of 1/2. This one is 1, it's always 1, the middle one's always 1, and then this is the base, 1/2. Okay, so now the h affects the x, and the a and the k affect the y. Like this. So negative 1 minus 2 is negative 3. Negative 3 times 2 is negative 6. Plus 7 is 1. 0 minus 2 is negative 2. Negative 3 times 1, negative 3, plus 7 is 4. 1 minus 2 is negative 1. And then negative 3 times 1/2 is negative 3/2, which is negative 1.5, which gives me 5.5 when I add 7. Okay, I'm going to draw the horizontal asymptote, which is at 7, y equals 7, right here on the top. And then the points, negative 3, 1, negative 2, 4, and negative 1, 5.5. About here. So the points are curving up like this. Okay, so the range is everything below 7, so it's from negative infinity to 7. The end behavior, as I go to the right, as the graph goes to the right, it approaches this line right here, so that's 7. And as I go to the left, as the curve goes towards the left, it's going down, so that's negative infinity. The y-intercept, I'm going to have to plug in a 0 for x. So that's going to be 0 plus 2 and solve for it. Negative 3, 1/2 squared plus 7, which is negative 3 times 1/4 plus 7, which is negative 3/4 plus 7, which is 6 1/4, 6.25. So that's the y-intercept. And that's it.